Is the Big Bang falling apart? Well, it looks like it is. And I'm here with Sal. We're going to talk about the new information that is coming out, the new reports that are coming out about the Big Bang. And it's just kind of an interesting development. Sal and I debated on the Big Bang last year. And I guess it wasn't last year, it was this year, wasn't it? But anyway, we have since our debate continued to see how the developments with the problems with the Big Bang have continued to come out. So tonight we're going to kind of read through some of the new reports. Do you want to say anything, Sal?
People have wondered why. Okay, I just first off, just for people who don't know me, um, I'm a Christian. I believed in theistic evolution and the Big Bang, but a lot of that changed as I actually went to secular school. I want to resist accusations that uh, I was committed to one particular interpretation of the Bible. Therefore, that's why I rejected the Big Bang and evolution. I'm just like, look, it started to fall apart on its own demerits, both theories, abiogenesis, evolution, and the Big Bang. And it was secular professors, not creationists, who were at my school. I studied under James Trefil, supplementary quantum mechanics at George Mason University. He was a big advocate of dark matter, and he wrote the book Dark Side of the Universe. He's a famous science writer, probably not as well known as Isaac Asimov, but he's very well respected. And in his book, The Dark Side of the Universe, he relates an account where he said a very senior professor that he knew, who he dare not mention, said, uh, I've been thinking about writing something about the big scientific controversies, putting it in an envelope, in a sealed envelope to be opened after I pass 50 years later. At the top of the list would be the lack of expansion in the universe, which is essentially that the Big Bang is false. I found that I found that astonishing. It's like, okay, so in freshman year, they're teaching us about the Big Bang, maybe a couple paragraphs in the textbook Halliday and Resnick. And then it really wasn't mentioned very much at all in my physics curriculum. We were too busy studying things like classical mechanics, quantum mechanics, electromagnetic theory, the basics of physics. And then here I go, I get to study under Dr. Trefil, and he has a book, and I said, that's really amazing. So even people that publicly will give one face to it, they have their reservations. If you ask them, they'll express it. It's not like it's a deep dark secret, but it's just like you got the feeling it wasn't fashionable to say there's a problem with our theory. What I've seen has been a change in just broadly in the whole scientific industry, which is actually beautiful, saying, hey, nothing's sacrosanct. I thought science is about being skeptical. Skepticism is supposed to be valued. What's the problem if you challenge the orthodoxy, especially orthodoxies that don't have any experimental evidence? And that has
Right.
been my big issue. I remember, I asked a pointed question. So I brought this up. Okay, so if you're speeding and you get caught and the police catches you with a radar gun, do you say, oh, the redshift in your radar gun was due to expanding space? Of course not. One, he'd laugh. And the police radar gun is not programmed. And I said, okay, so why do astronomers assume that? And they'll give their reasons, but I'm just pointing out, okay, there's a problem when you can't make a good, credible experimental argument. And then there's problems with the fact that the redshifts can be caused by something else. So that in sum is where I'm at. And I've
Right.
stood by my position and I will continue to. And all of these developments have not lessened my enthusiasm for criticizing the Big Bang.
So, yeah, there have been scientists who have criticized the Big Bang since the beginning. And more often than not, those are not the voices that we hear, right? They are typically silenced. One of those scientists who has, for 30 years, talked about the Big Bang and what the problem with it, and is Eric Lerner.
Mhm.
And I'm really happy to see that Eric Lerner is getting validated with these recent discoveries. And I'm going to read something that he wrote in a little while. But let's just look at this article that is from USA Today. The title is How Old is Our Universe? New study says the Big Bang might have happened 27 billion years ago. Well, just like that, the age of the universe doubled. Why? Well, because there are big problems with the Big Bang in the model that's currently put out, that it happened 13.7 billion years ago. Even though, how long have we been assured that that is the right age of the universe? Quite a long time. And now, just like that, in a flash, we're doubling the age of the universe. Now, I just I hope that arouses some skepticism in people. And but why is the age of the universe doubling? And I'm gonna say, or this is a proposal. I'm not gonna say it's a consensus, or that all scientists are agreeing with this, but thankfully there's enough scientists recognizing the problems with the galaxies and different things that are coming out with the new data. So I'm not reading the whole article, I'm just reading highlights, but it says, for years, astronomers and physicists have primarily calculated the age of the cosmos by measuring the time elapsed since the Big Bang and studying the oldest stars. But the study published in July 7th in the journal Monthly Notices of the Royal Astronomical Society seems to confirm that previous estimates were widely off. What's referred to in the new study as impossible early galaxy problem has long baffled scientists who struggle to reconcile why some galaxies thought to have come into existence long after the Big Bang appear to be, in fact, much older than the universe's estimated age. So basically, we have problems that, first of all, the galaxies that we're seeing, they are, if you just recently, if you would have Googled how long does it take an elliptical galaxy to form, you would find that it takes an elliptical galaxy to 7 to 8 billion years to form, something like that, right? And then that became problematic because with the JWST, we're seeing all these galaxies, elliptical galaxies, that close to when the Big Bang should have happened hundreds of millions of years after the Big Bang, and they're already fully formed spiral and elliptical galaxies, which tells you that they would have to be older than the Big Bang. So that's one of the problems with the Big Bang. But so what are they saying now? Now, this is a confirmation, Sal. You're going to like this, okay? Because remember that we've been talking about, and what Eric Lerner has proposed is that the universe is not expanding at all. And actually, our scientific observations of the galaxies and the distant starlight, and in the distant galaxies, the surface brightness test confirms that there's another issue going on, that it doesn't match with the expanding universe model. And so other models have been promoted, and one is that the reason we have the redshift is because the light is as it passes through plasma, then it becomes redshifted. It appears to us to be moving away when it really isn't. And now what you're going to like about this is that this scientist who published in the Monthly Notices of Royal Astronomical Society, he's saying this, that the tired light theory, okay, that originated in 1929, that was the explanation for the redshift, right? That it isn't due to galaxies moving away from us. It's that he's saying that this, if we allow Zwicky's theory to coexist with the idea of an expanding universe, we can reinterpret the redshift as a hybrid of both of these phenomena, and thus arrive at an even more accurate age estimate of the universe. So he's actually proposing that the way we calculate the age of the universe is to factor in this redshift due to light being, you know,
Well,
like slowing down.
redshift.
Or, yeah, redshifted.
Okay, so um, I need to amend something that I had said before over the last few months. I had mentioned specifically plasmas. We're finding there are studies that said even neutral molecules may actually do redshift very well, and that this is opening up huge avenues. Uh, the significant thing I need to emphasize: these are experimentally validated. Definitely for plasmas, we have to have. The one reason I wanted to get a PhD in photonics, and I'm still pursuing that, um, is to be able to do these experiments, we need to at least simulate light travel through millions of miles, because the effect in a laboratory laser that's inside a building is not a long enough distance. We have confirmed it with the Pioneer 6 anomaly that definitely plasmas will redshift. Additionally, there's something called the limb shift, also through plasmas. It's a different we still don't quite understand all the mechanisms. There is absolutely no doubt experimentally that they're redshifts. It raises the question why there's no blurring, but then it's like, well, then how come we're able to see things so clearly? And I'm just like, okay, this is a question we need to answer. It may be answered by neutral molecules. There's still so many open questions. And so the tired light theory, I wish they wouldn't use that term, because there's so many things that can count as tired light. There could be so many modes that can cause redshift. We have laboratory experimental evidence of this. If we can find a mechanism that can account for the absence of blurring, it's done. Um, there's not even a need for expanding space, in my opinion. But I would say this: look, I have seen from the Big Bang being certain. Now we have a climate. 40 years later, since I had kind of, I think I was in junior high school in the mid 70s, and I was so excited to tell teachers, hey, I know about the Big Bang. And they're like, very good, Sal. You know, you're really up on this knowledge. And the climate has totally changed. I mean, people are free to get on USA Today and say, I think this is, you know, maybe our timing was off. Tired light is okay. And I think this is kind of a step in the right direction we can start considering. And I don't know if you're going to cover that other article about the Big Bang expanding space being a mirage. I'm just like, okay, uh, it's kind of a euphemism for saying the Big Bang is wrong. So I think what is happening is, as I sense with my own professors, four professors at my school, a secular school, and they're not creationists. They're kind of expressing skepticism. James Treffel, whom I mentioned, was kind of in between. He's like, yeah, I think there's some big problems, but I believe it. But, you know, I have to concede there are problems, and my colleagues think there are. There were three other professors that were absolutely adamant this is wrong. I went to Johns Hopkins, and privately, some, you know, my professors are saying we're skeptical of this or that, even when their colleague Adam Rees was winning the Nobel Prize on dark energy. So what was happening, what we're seeing now in the press is kind of a bubbling over of what has been festering a long time. It's been simmering underneath. You know, I've been hearing professors, the graduate students are like, yeah, I'm going to go in another field. I don't believe this. There's no point in studying the Big Bang. I don't believe it. You know, I can do better in condensed matter physics, uh, you know, plasma
Right.
physics, electromagnetic theory, working on, you know, fusion or whatever. But why would I bother with cosmology? It's a mess, you know. And so a lot of times they have that inner skepticism, but they're not going to be on a crusade. But there's always been this simmering, like reluctance to say, you know, this doesn't feel right. Doesn't feel like a real theory, like say electromagnetism.
Right, exactly. And, you know, as just to be clear, the article that I'm reading, I'm not, I don't assume that he's making the right, you know, his hypothesis is correct. Actually, we assume it's incorrect because he's still trying to combine, you know, the expanding and the non expanding models. And so Just to read Eric Lerner's response to this article, he says, seriously, Dr. Gupta is to be congratulated for recognizing, as several other researchers have, that the expansion predictions are severely contradicted by the JWST data. And I only mentioned one of the contradictions. There are so many contradictions. There's the problem that we see with the galaxies being too small and bright and too massive for when we add in the expansion calculations. There's just the problem of uh, I lost my train of thought. I don't remember which other problems.
I can tell
Okay,
you.
okay,
So angular diameter test, that is
yeah,
absolutely failed. I mean, I've showed that diagram and people just like, I'm just like, wait, time out. This is really bad, guys. And they just dismiss it. And that actually is related to the surface brightness test.
yeah,
Again, dismissed. The issue of the absence of time dilation is controversial, but it's not unequivocally shown that there is time dilation. The quasar should pulse at a certain rates, and the supernova is supposed to, blow up and see them in slow motion, and then same for the gamma ray bursts. We have had arguments by credible scientists on both sides, so it's not a done deal that prediction. I would then say, hey, at the very least, why don't we just say we have our ideas, but let's not be dogmatic. I mean, I certainly have my opinions, but I think this is really premature. So, but the climate is changing because I'll tell you one thing that we should notice about equality theory. The more experiments and observations that are made, the more we're excited that it's confirmed. Some of the best examples are celestial mechanics. It confirmed the generally heliocentric nature of the solar system. We're able to fly space probes and satellites. It's like, this is a good theory. Everything it predicted, we have faith in it. It's good. And then electromagnetism. It's like people would laugh now if we say electromagnetism in its domain is false. It's like, no, look at the modern world. But then you look at the Big Bang and like, you keep having to have all these fudge factors and these adjustments and these anomalies. It's just like, this just does not feel like good science. You could say, well, part of science is speculation. That's fine. So let's just say this is on the speculative end. This is not yet at the end of what we call the platinum standard of a theory. So we could say it's good science as far as a speculation, but as far as experimental and observational confirmation, it's nowhere near the like the 5 pillars of physics, which I studied in school. Classical mechanics, quantum mechanics, relativity, electromagnetism, and statistical mechanics. It's nowhere near that.
right, yes. And, as I want to just continue reading a bit of what Eric Lerner said, he said, the widespread publicity for this paper introduced a broader public to the idea that there's a different explanation than expansion for the redshift phenomenon. This media notice also shows that the consensus cosmology is starting to crack apart. The possibility that the age of the universe, claimed to be precisely 13.81 billion years old, could be uncertain by a factor of 2, also contributes to discrediting the theoretical claims of the Big Bang cosmologists, which are contradicted by observation, the key test in science. However, this paper errs in trying to compromise between an expanding universe and a non-expanding one. It's either one or the other. Historically, some scientists sometimes try to sit on two chairs to avoid abandoning popular misconceptions. And so it basically, and then he explains why there's this compromise won't work. He says, hold on, I'm trying to just read the important parts. Okay, here we go. Because much observational data is incompatible with the predictions of any expanding hypothesis or any hypothetical hot, dense Big Bang epoch. Papers have been published that have shown the surface brightness of galaxies do not change with redshift, a clear test that only predictions based on a non-expanding universe have passed. So that's and additionally, the Big Bang hypothesis totally gets wrong the abundance of lithium and helium, and those wrong predictions won't be changed by tweaks to the Big Bang expansion hypothesis. So there's, if these developments, it's good that they're recognizing that there's a problem, and at least they're trying to work out other things. And you mentioned this article, so I went ahead and just pulled it up. But I thought this was really interesting when I saw this, that the expansion is a mirage. So this is another scientist that has recently, I'm trying to expand this so we don't have to see the ads. But anyway, it's researcher says the expansion of the universe is just a mirage. He might be right. So it's not just one person. It's not just one study. There are others who are starting to really explore other possibilities, that redshift does not equal expansion. And so the one that came out today was, a kind of a hybrid. So it's just interesting. One of the things Eric Lerner has said is like, oh, how great. He can just double the age of the universe with a couple of equations. Like, we've been assured for so long that we know the age of the universe, and we have all these ways of calculating the age of the universe. And now it's like getting ready to be abandoned, anyway, it just shows you can't be so confident when people are telling you can be confident about their calculations.
Absolutely. I have said, okay, look, I'm a religious person. People know that. And I have no problem saying, if someone says, well, I'm accepting it by faith. Okay, I respect that. I do have a problem if you say this is fact. And I can show that you really are accepting. It is more of a faith statement than it is a fact statement. I have a problem with that. If they just said, look, this is what we believe, we're awaiting more confirmation. I'm really fine with that. But when you look at the laundry lists of challenges, and I need to point out, and I'm going to credit you again for finding out, it was Hubble himself had said, nah, he came up with an alternate Hubble law. He said there's probably a redshift distance relation that is not based on expanding space. And you found that equation. I have to credit you. And so in even my cosmology textbooks, it says Hubble, essentially the father of expanding space. I'm like, well, that isn't his baby. He disavowed it, and he said, yeah, I did find a redshift distance relation, but I think the evidence argues against it. And I showed, when we were both on the debate stage, I showed a clip from a December 1941, amazingly just not too long after the Pearl Harbor raid, where he was in the midst of all that, a reporter managed to find him and get some statements and said, I think the evidence argues against an expanding space model, and future observations will help give us an explanation why. So if we're talking about skepticism, it really begins with the very person that in at least a lot of textbooks we're saying is the father of the Big Bang, and he's disavowing it. And so there's been a little bit of kind of like a little bit of spin and revisionist history. And I credit your investigation on all this, where, he said, I don't think so. And I thought it was a little irresponsible of the textbooks, not to mention that Hubble himself is reluctant. So, maybe I don't know how long it's going to be before the textbooks have to say, this is a contested area in physics. This is not as solid as electromagnetism or those five pillars that I mentioned, that are the staple of modern technology physics.
Yes, I thought maybe I would pull up the article that this is based on, the from the monthly notices,
And it's a real
because
journal, by the way, right?
yes, yes, it is.
So someone had questioned whether, because Eric Lerner published in this, whether that was legitimate. And I'm just like, okay, look, at least USA Today thinks it's legit enough.
It's quite a prestigious journal.
Yeah.
So, okay, and here's the title of the article, and let me just see if I can full screen this to make it bigger. Well, I don't know what's going on with my thing. Okay, I guess I have to accept all. So, yeah, but the title is JWST Early Universe Observations and Lambda CDM Cosmology. And I only have access to the abstract, so that's all we can read. Deep space observations of the James Webb Space Telescope have revealed that the structure and masses of very early universe galaxies at high redshifts, Z15, existing at 0.3 billion years after the Big Bang, may be as evolved as the galaxies in existence for about 10 billion years. The JWST's findings are thus in strong tension with the Lambda CDM cosmological model. While tired light models have been shown to comply, now this is very validating, isn't it? While tired light models have been shown to comply with the JWST angular galaxy size data. Okay, that's a precious sentence right there, right? Okay, they cannot satisfactorily explain isotropy of the cosmic microwave background observations or fit the supernova distance modulus versus redshift data well. Now, I'll just pick on the cosmic microwave background. We already know that the cosmic microwave background prediction was off by like a factor of 10 or something, right? I mean, it was like hugely off. And the cosmic microwave background, we really don't know what it's caused from. Like, people who want to say that the CMB is, remnants of the Big Bang, okay, that's one idea. But, there's other ideas for where the cosmic microwave background could be coming from. So I don't really care about that sentence there, or that phrase. But what about what it says here, Sal? I'm kind of curious. Let me finish reading and talk about this. We have developed hybrid models that include the tired light concept in the expanding universe. The hybrid Lambda CDM model fits the supernova type 1 data well, but not the JWST observations. We present a model with covariant coupling constants, CCC, starting from the modified FLRW metric and resulting Einstein and Friedman equations, and a CCC plus TL hybrid model. They fit the Pantheon plus data admirably, and the CC plus TL model is compliant with the JWST observations. It stretches the age of the universe to 26.7 billion years, with 5.8 billion years at Z equals 10 and 3.5 billion years at Z equals 20, giving enough time to form massive galaxies. It thus resolves the impossible early galaxy problem without requiring the existence of primordial black hole seeds or modified power spectrum, rapid formation of massive population 3 stars, and super Eddington accretion rates. One could infer the CCC model as an extension of the Lambda CDM model with a dynamic cosmological constant. And if this is really interesting, I feel like, as long as you're willing to hold on to the Big Bang model in some form, you can get published, right?
Yes.
But But anyway, so yeah,
I got to tell you, I I want to congratulate him as Eric Lerner did.
yeah.
Because if we, okay, so like I said, one of the tests was the time dilation tests. And they're both sides of this. It's not resolved. So if you accept that there's time dilation, expansional time dilation, not kinetic or gravitational, I'm sorry to be technical here, expansional time dilation, then this is kind of a good way to fix some of the problems. I'm not saying it's correct, but at least you could see the path of logic. And I want to congratulate him for entertaining the idea of um, components of the redshift that can be added by what's out there in space. That is totally reasonable. So overall, I'm positive of what he. I'm glad he talked about the angular diameter thing, and I did clip out from something you and I did. It's only 3 minutes, 3.5 minutes long. It talks about the angular diameter. If you'd like to share that with the audience, I don't know if we have the bandwidth to be able to manage it. It's only 3.5 minutes. It'll explain the angular diameter. Otherwise, we could skip it.
Well, let's just say this. Anybody who wants to know more about this, they can watch our video on it. I mean, you can pull it up if you want. That's fine.
I don't know if my computer's going to break down.
Okay, yeah, then why don't we
Why don't you,
direct them?
can you just provide the link to that I put in the private chat and
Yes.
dump it on the comment section, just in case people are curious what the angular diameter test is. And the way that I present it is kind of an elaboration of what he's saying in the abstract, that the Big Bang has failed the angular diameter test. I got a lot of flack for saying it the way I did, but it's nice to see in the Royal Astronomical Society, no less, I'm being affirmed that I was correct.
Yes. So, the part I wanted to focus in on here and just ask you about is this the observation. Okay, so it says that the tired light model does not fit the supernova distance modulus versus redshift data well. What does he mean?
Yes. Can you just read it a little bit one more time?
Yeah, but
I know what it is. The pure tired light.
Okay.
So it's exactly what I was saying. The supernova was dealing with this expansional time dilation. You should see the farther you look out. Okay, so like when you've seen an explosion, you can clock it, and so the prediction is the farther you look out, these supernovas should look like they're exploding in slow motion. And it's controversial whether they are, because you could cherry pick some that just happen to explode slowly and then ignore all the ones that are actually exploding quickly. And that's the argument David Crawford said. That's an illusion of cherry picking. And so he's saying, well, I think Crawford probably is wrong. I think we're actually seeing that slow motion expansional time dilation. Therefore, space is expanding. And he said, okay, so if space is expanding, and yet we have the JWST saying that the universe is much older, because we have that galaxy thing about these impossible galaxies. Hey, I figured a way I could solve the problem if we just have the best of both worlds. That's all it is. And I want to congratulate him for giving it a game try, where he took respectable, there's a lot of people that think that there's expansional time dilation. And I've been in certain communities, which you know about. There's a debate there whether there's expansional time dilation. There's not uniform agreement in all the cases. So he took the side of like, let's just accept it. So what I would say that would solve this is we need more observations to confirm or disconfirm disconfirm expansional time dilation. And since our debate, I found one by Petrosian on gamma ray bursts that I think is very devastating. And Crawford has argued. Um, I found out he was published in the journal Nature at least once, maybe a couple times. Was a Cornell researcher, so despite on the internet people are just poo-pooing him, he has good credibility. So what does this mean for the paper? If at some point this researcher finds out more credible evidence that there is no expansional time dilation, then it's a pure tired light model. And so he is very, very close. There's just one set of data that would probably change his mind, and that would be the expansional, because that's what he specifically cited. And
Mm-hmm.
I pointed out that this is a contested area, even in my circles, even in our circles, and even in the scientific circles. So I'm kind of excited that people might actually try to revisit this and re-examine
Mm-hmm.
the data. We're going to get, God willing, um, better space probes and space telescopes, and we'll have better answers. There are
Yeah.
there's so many areas of this. Um, we can't possibly touch on it, but I can't believe this is leaking out into the popular press.
I know, and that's what. And I wanted to highlight a couple of comments because Infinite Cosmos said is the 26 billion year paper available to read free anywhere. I looked for it, I couldn't find it. I'm talking about the journal article that I just pulled up. I could only get access to the abstract. But there's a lot of popular articles. I found the one that I read from in USA Today. There's one in Daily Mail, UK Daily Mail. There's one in another. Actually, I'll pull it up. It's like Azio Quantum or something. So
If you want, I mean, just between you and me for now, Rebecca,
yeah.
I do have university access. I mean, I have the privileges to read this. So
Oh, cool. Yeah, we can.
my university has paid for it, and because I am an alum, I get special privileges to have access to the library. Um, and I could at least see what I can at least do is say, hey, I've read this, I get it. He may not. I have a feeling he may not be saying anything that we haven't said, and that's because what you and I have said has actually been drawn from existing literature, and he may have found a clever solution. So probably the thing I would look for is to see what his justifications are for tired light. Um, I can already tell you that the angular diameter test, the JWST is. Why don't I just show the graph? Um, if I could
Okay.
share my screen, that way we could probably.
Yeah.
I'm gonna blow away my bandwidth here. I'll
And
just
I
share.
also want to just show Jamie Russell said GPS satellites have to be adjusted in microsecond on a daily basis because of time dilation. So I've been told.
Yes, that is gravitational and kinetic time dilation. That is not expansional time dilation. And I'm
Okay.
sorry to go
Yeah.
technical on you, but that's just uh,
Stephanie
that's
says hi. We're up late. Yes, she's up late too. We also had. I wanted to put up Slamarin said the JWST found the stretched out infrared light they expected to find in an out and expanding universe. Their models on how galaxies formed were off. That has no effect on the age of the universe. Well, thankfully, actually, it is like Sal said, leaking out into the popular press. Finally, people are admitting the galaxy problem. It's not just, oh, the galaxies were off. First of all, the they shouldn't be there at all. The galaxy shouldn't be there at all, right? But there's other problems with the galaxies, and here's one that Sal is wanting to show you guys. So I'll pull it up here, the chart.
okay.
Okay.
So this is mentioned in the abstract. It's very easy. The Big Bang model is the one that has this dotted curve. it predicted we were going to see lots of galaxies along this dotted curve in terms of the size, what we call the angular size. And where did tired light predict that it's going to be? It's JWST found all these red dots and it's clustering around the tired light model. And when I saw this, and Rebekah will attest, I started laughing. I couldn't stop laughing for a minute. I said, Rebekah, we got this. We've just blown it away. Because this is a prediction. This is a prediction of the Big Bang Lambda CDM model. When JWST saw these galaxies out here, we should be seeing the red dots on this line. Now, I go into this video. Rebekah provided the link, and I try to explain the mechanics of the angular diameter turnaround test. But the bottom line is, look, the red dots should be up here, and they're not. And he's saying, well, so it has to be the tired light model. And I have to, I'm like, yeah, how can you run away from this observation? The only recourse is to try to explain it away, which they're trying. And I'm like, time out. The first thing you're going to do is maybe blame the instrumentation because it doesn't agree with your model. You spent millions, maybe hundreds of millions of dollars building these instruments, and now you're going to try to say, oh, there's, it's kind of at the edge of the detection range. I'm like, look, you would be drooling if it were giving you the red dots around the Big Bang model. And I'm just like, okay, some people are realizing, no, this is a problem, but this is also related and through a very complicated line of reasoning that's too in depth to go into, surface brightness test. The reason we can see these things is because it's probably space isn't expanding. There's a quote by Michael Disney. He said, I was working on the Hubble Space Telescope with some colleagues. The cosmologist said, oh, don't worry about, seeing out that far. It's going to be all dark because the surface brightness will be gone because, the Big Bang effect will make all these galaxies look so big, and you spread the light out just like, as you move the projector farther and farther away from the screen, it gets dimmer and dimmer. He said, they said, forget it. He said, imagine our surprise when we saw, we looked out there and it was just full of galaxies. And that ties to the angular momentum surface brightness test. And look, you and I were getting a lot of flack when we were coming out, in the YouTube sphere arguing this. Isn't it satisfying? Someone in a peer-reviewed Royal Astronomical Society has just affirmed what we were saying 6 months ago. And
yes,
and someone
I'm very happy about it.
Someone in the comment section said they're finally catching up to Sal and Rebekah, or Rebekah and Sal.
Well, but okay, but let us not take credit because actually it's other scientists.
Other scientists.
It's and I'm not a scientist, but it's scientists who figured this out. We were just listening to the minority voice that was saying this isn't right. So it wasn't anything that we discovered. We were just taking people's work that had discovered the problems with the Big Bang. But it is very nice to have that minority voice validated. And I want to emphasize that this is why this is detrimental for the Big Bang. And it's not just about changing the age of the universe, but it's the entire Big Bang is based on the expansion of space. So if this expansion is not happening, the Big Bang did not happen, right? That is that is where the idea of the Big Bang comes from, is the interpretation of the redshift as expansion. If the redshift is not expansion, then there's no reason to think that the universe ever expanded from, a hot, dense state. Okay. So basically, as we're seeing the data coming out that's showing that this expansion thing isn't right, that it gives us very good reason to abandon the whole model. So, do you want to say anything about that, Sal?
Um, I thoroughly agree. If I looked a little distracted, I'm very curious about the title of the article and the author. I can look it up right now and just do a skim behind the paywall, and and I could just tell you in broad terms, did he basically use similar arguments, or are there data points that would be interesting that are new? So if you could, um,
Yeah, yeah, skim it. Yep.
can you type out the article name and I'll cut and paste, and also the author in the comment
Um,
section?
yeah, here it's actually, I'll just give you the, it's Gupta, R. Gupta, JWST. Here, I'm just going to give you the link to the one I'm looking at right now. So, okay. So, yeah, very satisfying. I'm going to look at the comments and see if anybody is saying anything here. Stephanie says, yes, they are admitting their model cannot be proven with the JWST. And actually, we're saying something stronger here. The JWST is actually falsifying their model. Their model is basically dead. And actually, it wasn't even the JWST data is damning, but there was already data out that was calling in the model into question. The Hubble Space Telescope data with the galaxies was already calling into question and making problems for the current model. So there were already problems, but it's just that the problems have only been compounding as the new data comes out. So and Infinite Cosmos earlier said short answer, yes. Long answer, no. It already fell apart a long time ago. Yeah, and so a lot of people that because Sal and I, we want to make our views known. We're not hiding who we are. We believe that God created the universe, and a lot of people that believe like we believe, they're creationists or believers in God. They like the Big Bang because the Big Bang, it means that there was a beginning of the universe, although now it's not popular to admit that the Big Bang is the beginning, and there's a lot of explanations about multiverse or different things that came before the Big Bang. And so it's not popular anymore to say that it was the beginning, but it used to be. The way that it was described in all the textbooks and everything was that the universe, that was the beginning of the universe, was the Big Bang. And there's a lot of creationist Christian apologists who liked that. They seized upon that because it gave them a good argument for the existence of God. And but I just want to, and so there, people may be reluctant to let go of this model because it kind of was supporting some of their arguments for God. But you don't need to hold on to this model. It's let's figure out what's true about the universe. Like, let's just find out what's true. If the model's true, then okay, great. But if it starts looking like it's not true, there's no reason to hold on to it. uh, you know but anyway, so the way that Sal and I see it is that this certainly looks, from all the observational data, like a ready-made universe. It looks like this universe was created, that it did not develop. And that's another thing that the data showed before. It's like we expected, as we looked farther out into space, that we would see all these mergers, galaxy collisions, we would see like things happening that would like kind of look back in time and be able to see the galaxies and things evolving, and we really don't see that. The farther back we look, it the farthest back we can go, everything seems like it's already in place. So anyway, that's you know, just goes along with what I believe, which is in the beginning God created the heavens and the earth, and he did, it didn't evolve, it didn't have to be developed by natural processes. And I think that is what our observations show. What are
Okay,
you finding, Sal?
okay, I just skimmed it, and thank you for covering for me while I was just busy just trying to log into my university, and I gave it a quick skim. Um, it is highly technical, as we would expect for a Memorial Society, Astronomical Society thing. I don't know that. Um, I I want to thank everyone who's so interested. They want to read the original, but it's going to be a tough read. And my purpose was saying, is there anything out there that you and I have already said that uh, would be reflected in the article? And the answer is yes. So what we've described, like that angular diameter video, that would definitely explain. I mean, he goes into the brutal math of it all, but I tried to show it intuitively based on what other people have said. I just wanted to say, I totally agree. I don't want to. I was only being kind of facetious and joking when I said someone actually did say in a comment section, the peer reviews caught up with Rebekah and Sal. Obviously, that was just a generous comment, and I don't think the commenter even meant that seriously. But it was his way of expressing. It's like, well, Sal and Rebekah had really done their homework and were adamant, and they really were not as far off the mainstream as they thought, because now some of the respected mainstream scientists are starting to come out and say, hey, look, I may not agree, but that was a good paper. Or now the climate, like Eric Lerner said, it's becoming fashionable to start to question expanding space, or at least put wrinkles in it, as in this paper. What I was looking for is if he mentioned specifically anything about specific tired light models, because it covers tired light could cover all sorts of mechanisms, and he did not. So the thing that I would have been interested in was not there, and that's okay. He's leaving that to other people to figure out. So I would say what we saw, what I saw in this paper, is very much everything that you and I have been saying. He's citing kind of the same ideas, except the one main difference for us is he agrees that space is expanding to some degree, because of the
Right.
supernova stuff. And I said that's controversial. If Crawford is correct that it's the supernova expansional dilation is not there, then um, he would have no reason then to make a hybrid model. So I do appreciate the fact that one data point he cited is a falsifiable. It is a falsifiable point, and then everything will fall into place, because then it could be a fully tired light model.
Right, because he says that the angular diameter, it matches the tired light
Exactly.
model. And
Exactly.
so the one thing that's getting in the thing that's getting in the way is that supernova time dilation, right?
Right.
And we don't know about, we need to do a little more work on that
And,
first
and
before. Mhm.
and if you will indulge me, if you have something else to say, I'm going to bring up one graph from Crawford's paper, and I want, because it's going to be compelling, because now, you know, it was a sacred cow, basically, not to criticize the Big Bang. It's becoming fashionable now. So any of the interested readers out there, it's like, okay, why don't we revisit some questions? Because I expect over the next few years, at the rate this is going, remember I gave a graph of you know, how my viewpoint has changed over the years because of the data that's coming out. I expect this thing about the expansional dilation in the supernova is going to get questioned at the rate we're going. There's not going to be anything that is not going to be questioned. So if you have something, I'm going to just try as quickly as I can to dig up this graph.
Okay, sure. Well, I don't really have much left to say. I think we've done just what we wanted to do tonight. But yeah. So I have nothing else to say, Sal. So hope you can
Oh,
pull
I
it up
better find
fast.
this fast because, okay, I got it on the archive, and I don't know if he has this graph. It's beautiful. I want to thank you for inviting me to join in this discussion. When he doesn't have the graph, I'm going to, if
Look
you
it
give
up.
me,
We can make a video later or something.
um, the, let me try this. Okay, I think I can find it. If you can give me 60 seconds, I think
Okay.
I can get it.
Sure.
And
Okay.
okay, so I'm gonna, if you can
Well,
let me
in the
share my screen.
meantime, oh, are you? Did you find it? Because I can pull
Yes.
something else up. Okay.
Okay. So this is the paper here, and let me see if I can expand this so you could see it a little better. And I love all these red dots and these dots. So if space, okay, so the paper that the Gupta cited said that you know uh, there was a study. Yeah, okay. Let me back up a little bit. What Crawford did is got some raw supernova data and said, "What's the evidence that um, they're the explosions are happening in slow motion?" And um, and what happened was they all clustered around. Okay, the ones close to us, which is here on the left side, versus the ones far to us, they all cluster around this blue line, which means we're not seeing any slow motion. And what he claims is these papers that said they got to see slow motion the farther you saw it, he says, look, they had to cherry pick all the points because most of the points are around the blue line. And so what happened, you have a whole bunch of papers that he claims, and I think he's made a credible argument, that unwittingly they were using circular reasoning. It forced them to end up picking all the data points and essentially cherry pick the ones that would validate your point without looking at the whole data set. And so
Wow.
this one by Gupta, if he cites specifically this, you know, uh, it is this controversy. If it is settled in the other way, I would bet he would be right there with the tired light advocates. Um, I don't like that word, but basically, our camp, Eric Lerner's, etc. We may disagree on the fundamentals. Um, we're creationists. He's not, but we would say that the space isn't expanding. And it's a phenomenon of whatever is in space, be it plasma or neutral molecules. So this is a very positive development because the Royal Astronomical Society is a big deal. All right, this isn't, I'm sorry to say this, this isn't some creationist publication or, you know, out there journal. This is a very respected journal, and that's probably why USA Today picked it up. And this is heartening because there's probably a lot of scientists out there saying, hey, we need a voice for our skepticism. I'm glad people are sticking their neck out. And by the way, it's kind of nice to see they're not being guillotined when they say it now. It's becoming fashionable.
Yes. Well, so, all right, we're excited about this. Don't know what's going to continue to happen, but we're glad that there's movement being made. And so we'll keep watching the news. Thanks, everybody, for watching, and have a great night.